Okay. So, good afternoon, all, and welcome to the another lecture of say BSc first year semester one. And we were working on the digital electronics. So today we are going to continue with another unit, that is unit two of RTM Nagpur University electronics syllabus, and that syllabus is basically related to the gates, right? And in my previous presentation, in my previous lecture, I have told you what are the gates and why they are called as gates. And so today we are going to learn more about the gates on say blackboard, so that we could understand how we are expected to write in your exams, in your theory papers, and what type of questions they are going to ask you, how to draw the diagrams, how to write the material on that, the stuff that we are expecting you to write, and what are the definitions of it. So that is what we are going to study today, and this is actually the easiest unit where you can score a good amount of marks. So just pay attention over there and try to recall those things. I will try definitely to mug up you all those things from my end. So just be attentive on this. So today we are going to start with logic gates, right? So we call them as logic gates because some of the logic is concerned with that. I guess this is visible to you. So we were working on logic gates, right? So why they are called as gates? Because some of the inputs are being given to the output, and that is why they are called as the logic gates. Now, the main important thing is what is a zero and what is one. So the whole digital electronics is based on these two terms, these two factors, that is zero and one. So where we call this zero as ground, or say it is known as off, sometimes it is known as false, sometimes it has many names likewise. So zero, ground, off, false, and say led is on or off, accordingly we name that. This is plus 5 volt, yeah, high, uh, or on, or true, or one more is there, that is called as low. So these are some of the terminologies which are related to that. While writing, we will be using those terms. So zeros and ones. So zeros is actually the ground terminal, which is at the lowest potential. That is called as ground. So we call it as zero. In during writing, we might use this word low for the zero, right? And similarly for one, or we might say it as a plus 5 volt, high, on, yeah, true. We'll be using high as a term synonym for that. So we'll be using these terms, zeros and ones, accordingly. So just remember these. So to start with, we are having 7 gates, 3 basic gates, 2 universal gates, and 2 special gates. So in all, we are having 7 gates on that. So the first 3 gates, those are called as the basic gates. So all the gates are being say all being constructed by using these gates. So we will use these basic gates. There are 3 basic gates. The first gate is AND gate, OR gate, and NOT gate, right? So to start with, let us start with the first gate. We call it as AND gate. So the pattern of writing, the points that we are expecting you to write in your exam, if this question comes, what is an AND gate? So or explore the AND gate, explain the AND gate and its truth table. So if this type of a question comes, what is that we are expecting you to write? So the first is the definition. So just see the definition, how I am writing this definition to you, and accordingly we need to write, right? So the definition will be like this. If, since it is having 2 inputs, if one, or first, if one and, this is that term that stands for AND gate, if one and second inputs are high, just remember this. If first and second, or if one and second inputs are high, then only the output is high, then only the output is high, otherwise it is low. So the output is high, otherwise it is low. So this is the definition of the AND gate. Otherwise it is low. So output is low, right? So this is the definition, simplest definition we are having. If one and the second, if the first and the second inputs are high, then only the output is high, otherwise it is low. The converse statement can be written as if first and second or both inputs are low, then the output is low, otherwise it is high. The converse statement is if first or second or both inputs are low, then the output is low, otherwise it is high. So remember this. This is for the definition. If we call it for the formula or the Boolean expression in that case, so Boolean expression will be y, we are taking it as the output. So y is equal to a dot b. So a and b we are assuming it as input, and y we are expecting it as the output, right? So I'm writing y over here. So y equal to a dot b. In some of the notes, these they say that these variables can be changed. So just don't get confused. It is for just understanding that why we are using as input and a and sorry output, and a and b are used as the inputs of that particular gate, that is idea. What is the symbol of that? So the second point you are expected to write is the symbol. So symbol of AND gate. So just see how I am doing that. So you have to make a D like this. It is D, right? A big D, and then we will be having two inputs over here. So just make it sure that it should come in between so that it will remain uniform. So A and B are the two inputs, and then we will be having one output from here. So we are calling this as Y. So we'll have a symbol like this. We'll have a D like this. A and B are the inputs, and Y is the output over there. So we are having two inputs and one output, right? So yeah, so first one is the definition, the second one is Boolean expression, third one is the symbol, fourth one is the truth table. So the fourth part is the truth table. That is what we are expecting you to write. So fourth one is the truth table. Now the truth table is the is actually the way in which we are supposed to give the input. So in how many types the inputs are supposed to be given to the gate, a particular gate. So let us try with this. So we will have a table like this. So we have two inputs. So probably there will be four types in which we are expecting to give the input. So this is A, this is B, and this is Y, which we call it as A dot B. And the probable inputs that we are expecting to give to this gate are, they might be given as 0, 0, 0, 1, 1, 0, and 1, 1. Likewise, so we are having four probabilities to give two inputs. They might be fully zero, they might be 0, 1, 1, 0, or they both will be high, right? According to the definition of AND gate, if you try to write the answers or try to write the outputs of this AND gate, that will be, if the definition says if one and second inputs are high, if first and second inputs are high. In the fourth situation we are having that situation, that if first and the second inputs are high, then only the output is high. That means it will be 1 over here at this situation, otherwise it is low, and otherwise the output will be low. So we'll have to write 0, 0, 0 for the other combination of the inputs. So the truth table will be A and B. Y is the output where we are expecting the output. A and B are the inputs. So the probabilities in which we are supposed to give the inputs are 0, 0, 0, 1, 1, 0, and 1, 1. The output will be 0, 0, 0, 1, right? Which implies that when the output is high only if both the inputs are high. If both the inputs are high, then only the output is high, otherwise it is low. So that is shown by this truth table. And we have to write the fifth point as the working of this. So we just need to explore this truth table that we have written over there. So how you are going to write this truth table, and just see over it, because in the next gate I'm expecting from your side to that you should be able to write. So just remember this. The fifth point is working. So in the first point of working, we have to explore or explain the first probability of input that we are trying to give. So input if input A and input B are low. So this is the simplest format that in which we are expected to write. If input A and input B are low, then the output Y, then the output Y is low. So this is the first point of the truth table. In the second point, what we are expecting to write, in the second point, we are expecting to write if input A is low and input B is high. If input A is low and input B is high, as shown in this truth table, then the output Y is high. So this is how we are expecting you to write, right? So this is the second working. Then we are having third. If same, if input A is high, if input A is high and input B is low, then the output is low. Then the output is low. So I guess it is visible to you. And last point, in the last point, we need to write that if input A and input B are high, if input A and B are high, then the output Y is high. So this is how you are expected to explain a particular truth table. So just remember, these are the 5 points in which we are expecting you to write. So the first point of any of the gates which you are expected to explore are the definition. The first point is definition. So you need to give the definition. If one and the second inputs are high, then only the output is high. Otherwise, it is low. So remember this, the way in which I am writing this definition might vary from notes to notes or books to books, right? So that is why I have expected from your side that you are not going to read any books right now. Just go through my notes, go through my topic which I am teaching you, and then refer the notes so that you will not get confused that whether I am correct or those books or notes are correct, right? So there might be a difference in language, there might be difference in the statements that we are having, but the actual meaning of the same actual meaning of the statements will remain the same, right? So in my statements that is developed by my own words, I have write like this: if first and second, if one and second inputs are high, then the output is high, otherwise it is low, right? We have a converse statement also: if first and second or both inputs are low, then the output is low, otherwise it is high. So we'll have both the statements, right? And then the second point will be the Boolean expression. So this is the first point in a gate, then this is the second point, this is the third point. Boolean expression of AND gate is Y is equal to A dot B. So A dot B, right? So we'll be saying that Y is the output and A and B are the two inputs given to a AND gate. The symbol of that is actually a D with two inputs and Y. So I guess it is proper if you see this. So it should look like a D like this, and we'll have the output coming out of this, and we'll be having two inputs like this. So A and B are the inputs and Y is the output. So this is the symbol. This is the third point of this. Fourth point will be the truth table. That is how we are supposed to give the input. and the fifth point will be working. So in the fifth point working, we are going to explore all the four ways in which we are supposed to give the inputs to a particular gate and what are the expected outputs according to that, according to the definition or according to the logic given to that particular gate. So that is what we are expected to write in the truth table. So as the definition is there, you might be understanding how I have drawn the truth table, right? So the definition itself says if one and second inputs are high, then only the output is high. If first and second inputs are high, then only the output is high, otherwise it is low. So in the truth table, I am shown that A and B are high, then only the output is high. Otherwise, all the inputs, all the probability of inputs will have zero, yeah, low as the output. So this is the truth table, and then we will land to the working. So in the working also we need to explore the truth table itself, that how many in which way we are going to give the input and what are the expected output that we need. So that is there, and this is how you are expected to explore or explain the truth table, right? So we will be writing working in 4 points depending on how we are expected to give the inputs to a particular gate. So this is about AND gate. So we'll continue for the next gate, that is the OR gate, right? So let us start with that. OR gate. So yeah, so now the second gate coming in this is the OR gate. So we are expecting the to write the definition itself. So the second gate over here is the OR gate. The definition is if I'm writing it like this, if first FIRST, if first or second, if first or second or both, just see, if first or second or both inputs are high, then only the output is high, otherwise it is low, right? Again, I am repeating it for you. So for the definition of a OR gate, if first or second or both, if first or second or both the inputs are high, then only the output is high, otherwise it is low. Conversely, we can say if first and second input are low, then only the output is low, otherwise it is high. Right? If first and second inputs are low, then only the output is low, otherwise it is high. Right? So this is the definition of, say, OR gate. What would be the expression? Boolean expression is y equal to a plus b. Again, we are expecting y as the output and a and b are the inputs, right? So Boolean expression is y equal to a plus b, and for the symbol of that, it's a little bit tricky. So we'll have a leaf strike type of a structure like this, right? And then we'll have a curve inside it like this. So it's like a leaf. So I'm again going to draw you. So while seeing that how it is being drawn, I guess it's very easy to understand. So this is like this. So a curve inside it, and we will have two inputs coming out of it at the center. So these are the two inputs, A and B again. So these are two inputs. This is not a bubble. Don't write bubble over here. So a bubble will make change in the input. Okay. So it is like this. I guess it's again a little bit tilted. So let me draw it very nicely so that, yeah, like this. And yes. It's a little bit in the downwards, so it's becoming difficult for me. Yeah, so it's like this. So A and B are the inputs, and this is Y, which is the output, and the equation is Y equal to A plus B. So this is the symbol. This is the Boolean expression. Let's go for the truth table. So the probabilities in which we are expecting to give the inputs are same. So A and B will remain same. Y is going to change. So according to that definition, Y equal to A plus B. The definition says that if first or second or both if first or second or both. If any of the inputs are high or both the inputs are high, then the output is expected to be high. Otherwise, it is low. So for say all the inputs one will be there, and for only when both the inputs are low, the output will be low. Otherwise, they are high. So this is the definition. This is the truth table 0, 1, 1, 1. So this remains the same. So we are expected to write this part as it is in all the gates that we are going to study, right? So 0, 0, 0, 1, 1, 0, 1, 1. And if you remember, we have studied the number system, and in that number system, if you go for 2 bits only, so you'll be able to see 0, 0, 1, 2, and 3. So this stands for 0 in decimal, this stands for 1 in decimal, this stands for 2 in decimal, and this stands for 3 in decimal. So they are serially coming over there: 0, 0, 0, 1, 1, 0, and 1, 1, right? So this is how this remains same. The output is going to vary. So the output will be 0, 1, 1, 1 in OR gate. While writing the working, if input A and input B are low, then the output is low. It is same. If input A is low and the input B is low, uh, wow, input A is high. Yeah. So input A is low and input B is high, then the output Y is high. Yes, this is high. And if input A is high and input B is low, then the output is high. So this will also come as high. And if input A and B both are high, then the output is high. So this is the explanation of working over there. So this is a second gate that we are need to study. So the first gate was AND gate. This is the basic gate. So first basic gate was AND gate. The second basic gate was OR gate, right? And the definition, the symbol, expressions, truth table, and working. This is what we are expecting you to write in the say theory. So this is OR gate. The third gate that we are expecting to study is the NOT gate. So the NOT gate, the third basic gate is the NOT gate. The definition of it is it's very simple. So the definition will be the output is the output is complement the output is the complement of the input. The output is the complement of the input. Implies that whatever we are expecting to give the input, the output is supposed to be the opposite of it, right? So it is just the complement of the input. It means that if you are going to give 0, then the output is 1. If you are going to give 1, then the output is 0, right? The Boolean expression is just simple. Here, this gate is having only one input, so we are using A as the input, and we'll be writing Y equal to A complement, which implies that whatever input we are expected to give to this gate, this particular gate, the output will be the reverse of it. So, coming to the symbol, this is a triangle with a bubble. So we'll draw a triangle like this. This is the which will have a one single input and one single output, and that will term as y equal to a complement. In some of the notes, it is written as a dash like this. So a dash. So a complement is or there. So this is taken as a complement. So whatever you are supposed to give in A, it will give you, it will reciprocate you the anti of it or the complement of that particular input, right? So okay, it will have a bubble also over here. Sorry, I missed it. So a triangle with a bubble is gives us a NOT gate. So this is the symbol for NOT gate. So as you are able to see, you are having only one input. So the table will also change. So I am writing a different table for that. So it will have only one input and one output like this. So A we are taking as input and Y we are taking as the output. So I have written A and Y equal to A complement. The probability is only 2. Either it might be 0 or it might be 1. So we'll continue it serially. So 0 and 1. So the output is going to change as 1 and 0. When the input A is low, then the output Y is high. Next one is when the input A is high, the output is low. That's all. So in working also, you will be writing only two statements. The first statement, when the input A is low, the output Y is high. Second, if input A is high, then the output Y is low, right? So this is the three. These are the three basic gates of say that we need to study over here, right? And two more gates are there. Those we call it as the universal gates, right? So for those universal gates, we will continue with that. So just hold for a second. Yeah. So the other types of gates are called as the universal gates. So basic gates are three and universal gates. So universal gates means the gates which can be used to prepare any other gates are called as universal gates. Means from these universal gates we can make any sort of gates, right? Therefore they are called as universal gates. So there are two universal gates. These are all again called as say the derived gates. So the first gate that we need to study is the NAND gate. So the NAND gate is the first universal gate. The definition will be similar to AND gate, just vice versa, right? Just reverse or complement of that. So what we have written in AND gate, if first and just remember the definition of AND gate. If first and second inputs are high, if first and second inputs are high, then then the output is high. What we have written in AND gate, if both the inputs are high, then the output is high. In NAND gate, we have to write the complement of it, which implies that if first and second input are high, then only the output is low. Otherwise, it is high. So otherwise, it is high. So remember this. The definition is reverse of AND gate, right? So AND gate is if first and second input are high, then the output is low. Otherwise, it is high. Remember this. Then what about the expression? The expression will be the same. The expression or the Boolean formula will be same. Y equal to A dot B. Just we will need a complement over there. So Y equal to A dot B complement. Now for the symbol, since I call this as the derived gates, which implies that we will have a AND gate like this. I hope it is visible to you. So we'll have an AND gate and we will add a NOT gate in front of it. So here there will be two inputs A and B. Here the output will be Y equal to A dot B, and at the end after the NOT gate the output will be A dot B complement. So that is why we call them as a derived gate, because the universal gates are actually derived from the basic gates. So we are using two gates. One is AND gate and we are complementing it by putting a NOT gate in front of it. So whatever we are going to give the inputs, they are going to be the reverse of the AND gate, right? Therefore, I have written if first and second inputs are high, then the output is low. Otherwise, it is high, right? So if you go for the truth table, this is the say circuit in which we are using and not gate. But for symbol, we have to give just a bubble to the AND gate. So we will be having this as D. Likewise, these are the two inputs. I guess it is visible, and we are having a bubble in front of that. So this stands for the symbol of NAND gate. So Y equal to A plus B, sorry, A dot B complement, right? So this is the symbol of that D with a bubble. So this bubble stands for the NOT gate that we are putting over here. So this is AND plus NOT will give you NAND gate. AND plus NOT NAND, right? So the definition, the symbol, expression, the symbol, And for the truth table, now anybody can tell me the truth table, what will be the output? Y equal to A dot B complement. Can anybody tell me what will be the outputs? 0, 0, 0, 0. You can unmute yourself and tell me. 0, 0,
Hi.
1. बोलिए 0, 0,
Sir.
Manish. 0, 0,
Yes, sir.
1. 0, 1, 1,
Yes,
1,
sir.
0, 1, and 1, 1, 0. So the definition says if
0.
if both the inputs are high, then the output is low. Otherwise, it is high. So if both the inputs are high, then the output is low. Unmute yourself, Manish. Yeah.
Yes,
So
sir.
right. So this is the truth table, and working you can write like this, whatever we have written. So this is the fourth gate. If input A and B are low, then the output is high. Yes, so the output will be high over here. Again, this will be same for both, and in the last we'll be having, if both the inputs are high, then the output is low. So this
Low.
these are the four working, right? Can you write this? So we have studied four gates. One is AND gate, second one basic gate is OR gate, third one is NOT gate,
Or
fourth gate is the universal gate that we call it as the NAND gate, right? So Manish, just mute yourself. Yes. So this is the universal gate, NAND gate, right? Now the second universal gate we are having is called as the NOR gate, right? So we'll be having this as the NOR gate. In that NOR gate, what we are expecting to have, we'll be deriving it from a OR gate and a NOT gate, right? So what would be the definition? The definition will be same as the definition of the OR gate, just the changes if first or second or both, if first or second or both inputs are high, then the output is low, otherwise it is high. If first or second or both inputs are high, then the output is low, otherwise it is high. So it is the complement of the say OR gate. So A plus B complement, that is what we are expecting to write. And in the symbol, again, we are going to derive it from the two gates, that is OR and NOT. So the we will be having like this. The structure will be like this. So we'll be having this OR gate like this. So we are having two inputs, so A and B. Here we will be having the output as A plus B, and in front of this we will be using a NOT gate. So at the end we will be having this A plus B bar, right? So this is the the circuit diagram of that. Or plus NOT will give you NOR, or plus NOT will give you NOR gate. The symbol will be same as OR gate, like this. So the symbol will be like this, simple, yeah, but with a bubble in front of this OR gate. So this will give you Y equal to A plus B bar. These are two inputs, A and B, right? So this is the symbol of that. A, B are the inputs, and Y equal to A plus B complement is the output. The truth table will vary accordingly. So we'll be having like this will give you 1, and the rest of it will give you 0. You can write the working of it. I guess you have understood these 5 uh, gates. So we have studied 3 basic gates, and or not. We'll just revise it within the next 1 to 2 minutes, and then we'll end up the class. So we have studied 3 basic gates, and or not, and 2 universal gates, NAND and NOR. The pattern of writing will be in 5 points. The first point will be the definition, the second point will be the expression, third point symbol, fourth point truth table, fifth point working. So working, you are going to explore the truth table itself, right? So the first in the definition, first definition is, I guess it's over now. So we'll end up the class here. See you in the next class. Go through my YouTube channel. I will be uploading this video again. Bye. Take care. See you soon in the next class tomorrow at the same